Hello, classmates. We have previously learned about rectification, filtering, and voltage regulation circuit. Today, we will proceed with the task operations of this project, the design and fabrication of a direct current power supply. Next, please listen as the teacher explains the task analysis and the operational precautions. The goal of this section is to be able to independently carry out the assembly, testing, and debugging of the circuit. According to the process requirements, be able to independently check for and troubleshoot faults that occur during assembly and debugging. In electronic devices, the internal circuits generally require a direct current stabilized power supply. These direct current powers, apart from a few that are directly used from dry batteries and direct current generators, most are obtained by converting alternating current. That is, means electricity into direct current using a direct current stabilized power supply. It's shown in Figure 121. It is a commonly used single-phase bridge type rectifier capacitor filter voltage regulation circuit. It can provide a stable direct current power supply to the load. The circuit consists of 4 parts: transformation, rectification, filtering, and voltage regulation. Among them, the transformation circuit consists of a power transformer that reduces the mains voltage of 220 volt to the alternating current value required by the circuit. The rectification circuit, made up of semiconductor diodes, forms a bridge rectifier circuit, which converts the secondary alternating current voltage from the transformer into pulsating direct current voltage. After passing through the capacitor filter, it is supplied to the shunt voltage regulation circuit composed of a voltage regulator tube to obtain a smooth, direct current voltage that meets the needs of the load. The project is to complete such a single-phase bridge type rectifier capacitor filter voltage regulation circuit, and its fabrication and debugging in situations with higher requirements. A more complex voltage regulation circuit is needed to meet the load's demand for direct current voltage. The direct current power supply circuit diagram shown in Figure 121 can be represented by this block diagram to show its composition. The direct current stabilized power supply consists of a power transformer, rectification, filtering, and a voltage regulation circuit, which are 4 parts. We have already understood and mastered the working principles of rectification, filtering, and voltage regulation circuits. It can also be seen from the waveform diagram in the figure that the input alternating current is ultimately converted into stable direct current. This way, we can provide a stable direct current power supply to the load has been provided. The alternating current voltage UI supplied by the power grid is 220 volts at 50 Hz. After being stepped down by the power transformer from the secondary side of the transformer, we obtain the alternating current voltage required by the circuit. The secondary voltage for this task is alternating current 9 volt. Then, it is converted by the rectification circuit into a pulsating voltage with an unchanging direction, whose magnitude varies over time. Then, the alternating current component is filtered out by the filter, and a relatively straight direct current voltage is obtained. However, such a direct current output voltage will still fluctuate with the alternating current power grid voltage or changes in the load. In situations where higher demands are placed on direct current power supply, a voltage regulation circuit is also needed to ensure that the output direct current voltage is more stable. The voltage rating of the selected filter capacitor in the circuit should be higher than the theoretical value of square root of 2 U2. That is 9 square root of 2 volt, and there should be a certain margin. In this task, the capacitor capacity is chosen to be 470 UF 50 volt, which meets the requirement. This task uses a silicon voltage regulator tube for parallel voltage regulation, selecting the 1N4735 model tube with a voltage regulation value of around 9 volt. The current limiting resistor selected has a resistance value of 200 ohm. The task production should follow the steps below. First, prepare the components according to the material list. Then, proceed with the inspection and selection of the electronic component. First, visual quality inspection. Electronic components should be intact and undamaged. Various models and specifications markings should be clear and firm. Symbol signs must not be blurry or fall off. According to the methods previously mentioned, test each semiconductor diode, silicon Zener diode, electrolytic capacitors to see if they meet the circuit requirements. For this task, we use a single-strand insulated wire to complete the circuit connection on the experimental board. It is important to note that when installing components with polarity, such as electrolytic capacitors, rectifier diodes, voltage regulator diodes, etc., do not install them in reverse. Pay attention to the correct polarity, otherwise the circuit will not work properly, or even burn out the components. Now, let's proceed with the wiring. D1 cathode to D2 cathode. D3 anode to D4 anode. D1 anode to D4 cathode. D2 anode to D3 cathode. U2 equals 9 volt. D1 anode to the 9 volt on the secondary side of the transformer. D2 anode to 0 volt. Using a 470 microfarad capacitor, so D1 cathode to the positive terminal of capacitor C2, D3 anode to the negative terminal of the capacitor. Select a 200 ohm current limiting resistor, C2 positive to the left hole of the current limiting resistor, C2 negative to the positive of the voltage regulator D5. The circuit inspection and debugging, divided into visual inspection and power-on inspection in 2 steps. 1. Visual inspection. After the circuit connection is completed, first, Do not power on. Compare with the circuit schematic diagram or connection diagram. Check each component and wire. Check whether the circuit connections are correct, whether the component polarities are reversed, whether the contacts of the component pins and wire ends are good, whether the wiring meets the requirements, etc. 2. Power on inspection. After visual inspection, connect the negative of the volt regulator D5 to the positive of the direct current voltmeter, the positive of D5 to the negative of the direct current voltmeter. Select a 20-volt range. Turn on the power supply. Turn on the direct current voltmeter. Check if the output voltage is around 6 volt. We can see that the direct current voltmeter shows around 6 volts. If not normal, immediately cut off the alternating current power supply. Recheck the circuit. If normal, connect the load at the output and use a series of 1K resistor and 100K potentiometer as a substitute. And insert a direct current meter in series in the load. Select the 10 mA range for the direct current. Adjust the potentiometer. Observe whether the output voltage is stable at around 6 volts. You can see that with the change in output current, the output voltage remains stable at around 6 volts. Alright, that concludes the content for today's lesson. Goodbye, classmates.